So today we will be seeing our first image model. Although we have done it earlier also when we were dealing with image data set, we actually saw how to do image classification. So enough done doing classification problem. From today onwards, we'll focus on object localizations and object detection kind of problem. Okay, and these two are the prime cases we try to solve using uh, deep neural network. Okay. So for that, there's a one very important library we have, and that library name is CV2 Computer Vision 2. Okay, so any kind of image problem you're trying to solve, this library is mandatory. Okay, and if you're working with Google Colab, this library comes handy with that. So no need of installing this CV2 library. But if you're working with some other integrated development environment like PyCharm or Visual Studio, installing this uh, library can be a big challenge, big headache, because it has a lot of dependencies and sometimes it cause a lot of problem while installing it. I would suggest, if you're not using Google Colab so far, while doing the image problem, please use Google Colab. This is number one reason. The number two reason is image computation task or any image problem are very computationally expensive task, right? It requires a good amount of RAM, it requires good amount of processor, uh, some high end configuration it required, which is not really provided by your general computer, right? For example, you see here, when I'm using a Google Colab, I'm using a RAM of I think 12 GB, which is which is really a good configuration, and it provides me GPU also. So if you want to see here, if you go to runtime manage session, wait, not this one, runtime, change runtime type. If you go here, so hardware accelerator, if you drop down, you will see that GPU and TPU, right? GPU, graphical processing unit, and TPU, tensor processing unit. So this is the main ESP of Google Colab. This thing is not really, available in the local system. So that's why I prefer to always use with Google Colab. If I'll just use click here GPU, uh, my I would be able to use GPU instead of CPU for doing all this processing, and you'll see that the output will be really quick. Okay. Uh, if you'll go to the market to buy a system which have these configurations, at least it will cost you 3 to 4 lakh rupees. Okay.
Wow. So I saw that when you were showing the GPU, TPU, both of them are not selected. So what is it by default then?
By default, it is CPU.
Oh, it's a CPU. So TPU is something
And
else.
TPU is tensor processing unit. So again, TPU is used for solving TensorFlow problem, image problem, but we won't be needing that level of resources. What happens in Google Colab, it's a shared resources. If you'll keep your system idle for some amount of time, your session will terminate, and it will allocate your GPU to someone else. So if you are using a TPU, if you have went for TPU option, but if you're not using your system for a while, automatically it will terminate your session, and all the progress that you have done, it will lost. That's why, as per the need, select your runtime unit. I feel in this particular problem, CPU itself is sufficient, because today we're not going to do some really computationally intensive work. So I could have chosen none also, but still, I'm taking a GPU here. Okay.
Okay.
If you are solving a real life problem, office related some issues, go for TPU. You'll see the difference. Okay. All right. Yeah. And all the library that we're gonna see here, they all support parallel computing. Okay. So that's a beauty about computer vision library, because everybody knows that typically if you deal with any HD image or HD video, the number of pixel you'll be having huge, right? So it's it becomes very important that you work with some good configuration laptop when you're solving this kind of problem. All right, yeah, enough the theory part. Computer vision library, we all are clear, right? The next library which I need for today's exercise is matplotlib. So by now you must be pretty much well versed with this library. Matplotlib is used for plotting, right? And we would be needing some sample images, right? So I have image here, which I have locally ingested in my system. Where is that? It will give me an error. All right. Let me download any image of signal. Stop. Okay, I need it in PNG format. That's why what I'll do is I'll just do. So you understand what I'm trying to do here, right? I'm trying to save an image over which will apply our object detection. Okay.
But why are you again changing it? Like you said, it's a PNG format, so you want in JPG format?
No. See here in my code, I'm supposed to use here an image, right? Here I have
Yeah.
to use image, but I haven't kept any image in my workspace. My workspace is empty.
Yeah.
That's why I'll be pushing one image here over which I can show you the object detection.
Okay.
And this image I want in PNG format. That's why instead of copying, I am taking a screenshot here. Because if I'll copy it, it will save in JPG format. Now so now next thing what I do, I need to push that image in my workspace, right? So I'll manually upload that image here. Right. Okay. So my image is uploaded in my workspace. Let me check if the process is complete or not. Okay. Here, me copy the path. Yeah. Okay. So these two lines is clear, right?
Yes.
Okay. Now to read an image, we use a function that is provided by this computer vision library, and the name of that function is imread. Very intuitive, right? Image read, imread. You need to pass the path of your image as argument. Okay. And we are storing our image in this variable img. Right?
Yeah.
After that, what I'm doing is OpenCV opens image in BGR format. So what is BGR format? Blue, green, red format. But we want this image in RGB format. Okay, so by default, what happens is this CV2 library, it reads an image in form of BGR, but we are used to, to seeing RGB images, right? RGB image, you understand, right? Colored images called RGB images, right? And also what we are doing is here, once we have read the image, we have to convert this image in a format which is uh, in the way we perceive images. So here, first of all, what I'm doing is this image which is in BGR format, I need to convert this image into RGB format. For that, I'm using BGR to RGB.
They are converting into two formats, gray and RGB.
Yes, gray. So why I'm doing it in gray format is we cannot directly convert this BGR format into RGB format. There's an intermediate stage in between that, and that stage is called grayscale format, right? After that, what I'm doing is
Oh,
I'm
so why if you don't do gray, you just cannot do RGB directly? Because the value says color
yeah,
underscore BGR to RGB, right?
yes, yeah. So the process which I told you, right? It is happening as a part of this function. So this function
Oh,
will
okay.
take care of it,
Okay.
right? So right now what I'm having is I started with this colored image which was in BGR format. Now from
Yeah.
that I am having two more copy of that image. One is in the grayscale format, the other is in RGB format,
Okay. Yeah.
right? If I have to show you this grayscale format
Yeah.
here, instead of this IMG RGB, what I'll do is IMG gray.
And what is that? 111 in subplot?
111, yeah, I'll come to that part. I haven't reached there. Right now I'm at this step. Till here, anyone, any problem?
No.
Okay. Now coming to this part. So right now I have converted this image into two format. RGB format is the colored image version of it, and this is the grayscale format of it, right? And now what we do, we want to display those images, right? So for that, first of all, I am creating a plane for displaying. So this function plt.subplot is exactly doing it. What it is showing that I want to create a plane which will have dimension 1 comma 1 comma 1. That means one row, one column, and I want to keep that image in my first position. That's why 1 comma 1 comma 1. If there were two images to display, I could have done something like 1 comma 2 comma 1,
So
right?
the second index is pointing to number of images.
No, this is pointing to your number of rows, this is
Yeah.
pointing to your number of columns, and within that, so if you'll have this number of rows and columns, it will give you a feel like a matrix, right?
Yeah.
And within that matrix, to which position you want to keep this image. So it defines the position where you want to keep your image. So since I'm having only one position, because I'm going to create a matrix of one row and one column, I'm having only one position. That's why it is one here.
So you're saying that basically subplot is plotting image itself is a like a matrix, right? It is in the
Yeah,
form of rows and columns,
yeah.
right?
See, it does
So
something like this. So when I do this subplot one, let's say I'm doing here two, two, and one. So what it will do, it will create a plane of two cross two, right? This is it will create some plane like this. Sorry for this haphazard diagram. I'm not using pen today. So it will create a plane like 2 cross 2. And within this plane, if I do right here 1, that means from this grid, I want to choose first position. So this is position 1, this is position 2, this is position 3, this is position 4. Okay. So whatever image I'll be showing, it will place itself in this particular part, right?
mm,
In this case, since I have this subplot 1 comma 1, right? That means what? I'm having one row and one column. This is the 1 cross 1.
so
One row
one
and
row and one column means there's only one
yes,
like, right? So
yes.
one point.
Correct. 1 point. And this, what is the position of this point? One only, because I'm having only one box. That's why 1 comma 1 comma 1,
Okay.
right? So normally the subplot is used, this function is used when you have multiple number of images to display. Is this part clear, everyone? Okay. Now I want to display that image, right? So for displaying that image, I am having a function called IM show. which is a part of matplotlib library. Okay, and that after that you just need to write plt.show so that it will display to the user. Till this part everyone is clear, right?
Yeah.
Okay. Now, see, now the problem, now let me explain you what is the business problem we are trying to solve here. We will be having a lot of images, right? And in that images, we want to we want to identify stop sign. Right? So in this images, I want to identify where the word stop has written, and I want to draw some sort of a bounding box. Okay. One of few of the practical application that you will see of this problem, which is right now running in the market, is uh, people, I mean, for surveillance purpose, the police department used to place camera in the traffic signals, right, which identifies the number plate of vehicle, right? And what happens if anybody who jumps the traffic rule, what they will do is they will take a snapshot of their vehicle plate, they will identify the numbers, and based on that number they will do some lookup and identify the person name, and they will send some challan to their respective home. This is one of the practical applications we have. In medical applications, what application you can think is, you in input you'll pass an X-ray report, right? And in that X-ray report, maybe there's some hairline fractures or bone dislocation. So it will identify whether that X-ray is having that bone dislocation or not. If it is having a bone dislocation, then it will draw a bounding box on top of it, so that doctor need not to manually look for the places, he need not to invest time reading that X-ray image, and there's some saving of time, right? So like this, there are n number of applications, right? Now, see, so for this recognition problem, right now we're not going to create some neural network for identifying this object. Rather, we are going to use a function called detect multi-scale. Okay, so this detect multi-scale function, it is a part of OpenCV library. Okay, so with this function, we will try to identify where is the stop object in my image. Okay, and for that there is something called classifier. Okay, so here we're going to use a Cascade classifier. So what people have done is, they have trained a neural network to identify objects, and after that they create an XML file out of it. So what that XML file contains, it contains the information related to this specific part, this sign part. Okay, so it information, as in it contains the feature description of this part, right? For example, let us try to explain you with a real with more intuitive example. Is, if you are standing in a big queue, right? If you are standing somewhere in between a huge crowd and I have to identify you, right? How would I identify? First of all, I should have your feature description in my mind, right? If somebody will come and tell me that you are using today, you are wearing a green shirt, black pant, this color of shoes, you are this much tall, some information about your complexion, hair color. If I have all this information with me, then I can identify you from that crowd, right? Is this part clear?
Yeah.
Similarly, that XML file will have all the feature description about these signs.
Which sign? The stop sign?
Yeah, this stop sign, because I want to draw a bounding box on top of this stop sign, right?
So basically that XML file will probably be containing information like what is the color in it, what is the shape of that object, right?
Yes, yes, yes. So it won't be a very that straightforward rule that anything which is in the red is maybe the stop sign, some stop sign will have an alphabet S, T. It won't be that straightforward. It will be a set of rule, and in that set of rule, it will have millions of rules. Then only it will be able to encompass broader set of stop sign, right?
Yeah. So I have a question. So you said that OpenCV already has some function which is doing this work of detecting the object, but
Mm-hmm.
then you also talked about some classifier. So if OpenCV already has a function which is detecting, then why do we need a classifier?
No, no, no. So for that function, you need some raw material, right? So you can consider this XML file as a raw material. How this XML file will be utilized, that is taken care by this function.
Which
But
function? The
uh, this one, detect multi-class, multi-scale,
okay.
right? So similarly, if you don't want to determine the stops and you're interested in some other object, right? So you need to provide the
Mm.
this feature description of that other object.
Yeah, but my question is, detect multi-scale function is doing that work of identifying the object. Then what is multi-classifier class doing?
It is making the use of that input which you are giving XML file. See, what you are giving is XML file, right? That XML file is in very unstructured way. It is just having the set of rules, but how it will use that set of rules to identify that specific part out of that frame, that function is doing that task.
Which function?
Multi-scale, OpenCV multi-scale.
So that means the multi-scale function, if I just give it the image, it will just don't know what to do, right?
Yes, you need to provide the XML file for that.
So why can't I give the XML file directly? Why I saw that you had given XML file to the classifier. Output of that classifier, you're giving it to the multi-scale function, right?
Yes,
Yeah, so that's what I'm not able to understand. Why are you doing that? You can simply give the XML file to the multi-class function.
yes. Let me share my screen again. For some reason, I don't know what happened. Uh, wait, I'm sharing my screen. Is my screen visible?
No.
Okay, just give me a second. Also, since there are multiple tabs open now, I have messed up with some part of my code. I was I was about to copy paste that image location to another file, but paste it to some other file. So I'm just looking where is that original file which I'm supposed to show you. Mm, some version of my Google Colab is changed. It is not recognizing my CV library. Okay, let me reinstall this again. Okay, 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 I understood. I actually, the version of my OpenCV is changed. Let me correct this one. Let me, is my screen, is my screen visible to you?
Yeah.
See, what happened with my system? Let me explain you that part first. So I accidentally overwritten OpenCV version with the newer form of it, right? And because of which, when I was running the code, it was giving me an error. So I again, reinstalled my OpenCV functions, and then it worked fine. So same thing can happen with you also whenever you are developing something. There may be a situations where the version of file which you're having in this Google Colab, it may be outdated, and there may be a situation that you have to update that version. So what you can do is, like, you can simply do this exclamation sign pip install and the name of your function here. Okay, and it will overwrite the package which is there in the Google Colab by the latest version of it.
But doesn't Google Colab already should take care of that, right? Like if
Yes, 90% of the time it does, but sometimes what happens, since there are millions and millions of packages in Python, so sometimes it happens that the update happens a bit later,
okay.
right? So Google, so you'll see that you'll not find all the package already available with the Google Colab. There are a lot of functions which you need to install manually also. So what Google does is it will just keep the most commonly used functions in your workspace by default. But if you are using some functions which is very rarely used by developers, in that case you need to install it. And the way of installing functional library is very simple. You need to start with exclamation sign and pip install the name of your library. Okay. 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 What another thing which I did is I just replaced that image with another image which is in JPG format. Okay, so initially I was using a PNG format, but I'm using a JPG format. It's absolutely fine if you want to go with PNG format only. But the function which I have written at the bottom, that it is more suitable for JPG format, because this stop underscore data XML file which I'm having, it is for the JPG format. Similarly, if you want to do PNG format, you can install for PNG as well. Okay. So till this part we were clear. Now your question was about the stop data XML file, right? The stop data XML file, it has the feature descriptions of your image, right? Now,
Yeah.
now see this, you are providing your this feature description part to your Cascade classifier, so that your Cascade classifier will be able to know that how exactly your object looks like, right? And then you, on top of this, you will be applying detect multi-scale functions of OpenCV, and that will help you to identify your desired object in the image. If in case you want, instead of, let's say, not if you're not interested on detecting the stops and you want to detect cars in your image, right? So you'll just pass here cars.xml. First of all, you need to install that car underscore xml file. right? You need to keep it in your workspace, like the way I have kept for stop sign, right? You
Hmm.
need to pass that XML file to your Cascade classifier so that your classifier will get to know that this is a description of your desired object.
So are you saying that the Cascade classifier can detect any object? Say the XML file has the,
Correct.
it contains the information of a keychain, a key,
Yes.
right? So
Yes.
Cascade classifier is basically classifying between different outputs and telling, oh, this is most likely key,
Yes.
right?
Yes.
So this is my confusion. If classifier has already done that job,
Hmm.
then what is multi-scale detect
Yes.
multi-scale doing?
Yes. Yes. So see, this classifier will be will learn from this XML file, right? But that learned version is still in a very raw format, right? So
Okay.
for example, how a code executes. Whenever we write a Python code, first of all, it will create a bytecode of it, right? And after that bytecode, uh, interpreter will work on that, and then finally executable file is created, right?
Yeah.
So it is exactly like this only. This is a raw material. This raw material will be utilized by this Cascade classifier for learning. Once it has learned, that learning is still in very raw format, right?
But you see, Ashutosh, in our earlier examples where whatever we learned, right, we
Mm-hmm.
have always been just playing with classifier. We further did not
Yes.
do anything to further find our answers, right? Whatever
Yes.
classifier said, we said, oh, okay, we got the answer. Like this is the
Yes.
90% chance it is saying that it
Correct.
is. So why
that
then here extra?
that was different sort of problem. That was the classification problem, where we have to classify object with some probability score, right? This is object detection problem.
Okay, okay. So you're saying because it is object detection, as in it's like visually detecting an object.
Yes.
So just the classification is not enough. We
Yes.
have to use some
Yes.
more technique or functions to make
Correct.
it detect, to visually see it.
Correct. Correct. Here we are
Okay,
not
okay.
just saying that this image is containing apple or banana. Yes, is when it is saying apple, and if apple is our desired class, we are creating a bounding box also.
Oh, got it, got it, got it. Now I understand.
And then this thing we are using by our detect multi-scale functions, right? And after that, what it will do, it will scan your image, and it will, first of all, it has learned that feature, right? How your exactly stops and looks like. And after that, it will detect on that image. And once that it has detected, it will draw bounding box. So to draw bounding box, you need to have some dimensions, right? You need to have the dimensions of that rectangle. So how we are figuring out that dimensions of rectangle is by doing some lookup, by using a for loop that determines its length and width and height of bounding box, right? And after that, if I'll run this one, you'll see that in that image some bounding box is created.
Yeah, so can you go up?
Yeah.
Can you go a little up? So you so found variable is containing the
Yeah.
detected object, right? Then you are using x comma y comma width comma height in found.
Yes.
So like we're using four variables. So what is
Yes.
x and y? X and y are the coordinates.
Yeah, x and y is, yeah, definitely it is the coordinate. So it is x coordinate, y coordinate, and then width and height. See, it is giving you the dimensions of your bounding box. Let me print this one, then I think it would be making more sense. X comma y comma width comma, okay. See here, it is giving you the location where it has to put the bounding box. So you see here, First of all, the first point is what? 144, which is somewhere here.
144.
You see that from the x-axis.
Yeah, 144.
And this was the value of x.
Yeah.
What is my y? Y is what? 66, right? So 66, if we look from here.
On the left side.
Yeah, here.
Yeah.
This is 66. This is 0, right?
Yeah.
This is 66. This is y.
Yep.
Right? And after that, what is the next value? We are having 315, right? So if you look 315, 315, where exactly this is 315?
Between 300 and 400 on y-axis.
Yes, somewhere here, right? If you look from this axis.
Yeah, but why you're saying it's on the right side? Even on the left side, there's it is 315, right? No?
Okay. Yeah, you're actually correct. Yeah. Wait. What I am saying here is, so this x and y coordinate we have identified, right? This and this point we have identified from x and y, right?
Yeah.
After that, what I need